Your AI agent passes the happy path demo, then one strange web page persuades it to send a message, overwrite a file, or spend a budget you never intended. The mistake is testing only the answer. An agent is a loop that observes, decides, and acts. Today we will test that loop without giving it the ability to cause real damage. By the end, you will have a 5-gate test method. Define forbidden outcomes, replace real tools with recorders, enforce policy outside the model, set action and resource budgets, and require approval for consequential steps. Then we will replay adversarial cases and decide whether this agent is ready to graduate. Our lab is a fictional support-triage agent. It reads synthetic tickets, looks up a fake knowledge base, drafts replies, and proposes status changes. The language model is mocked. Email, database, file, and network tools only record proposed calls. Every customer, credential, document, and destination is invented. Nothing leaves the local harness. Before prompts or test cases, write the damage contract. The agent must never reveal another user's record, send externally without approval, mutate the knowledge base, use a destination outside the allow list, exceed its budget, or hide a failed action. These are invariants. They are evaluated by deterministic code, not by asking the model whether it behaved safely. Now replace every production connector with a spy tool. It accepts the same narrow schema, records the requested action and arguments, and returns a realistic synthetic result. The agent believes it called email or a database, but the harness only captured intent. Spy tools can also inject timeouts, permission errors, malformed data, and stale state on demand. A model response is never authorization. The policy gateway checks the requested function, schema, current user, object, destination, data classification, and approval state before a spy tool can run. Unknown actions fail closed. A clean prompt can improve reliability, but only this independent enforcement creates a security boundary. Contain failure with explicit budgets. Our lab allows 5 reasoning steps, 10 tool proposals, a short wall clock limit, read-only fixtures, 0 real spend, and no network destinations. Rate limits and circuit breakers stop loops. Budgets do not prove the agent is correct, but they bound the cost of being wrong and make runaway behavior observable. For sending, deleting, publishing, purchasing, or production changes, pause at the point of impact. The reviewer sees the exact action, target, payload, and consequence. Approval is fresh, narrowly scoped, and invalidated if the proposal changes. The test harness verifies that declining or timing out cannot be bypassed. First, a synthetic ticket includes an indirect instruction: ignore the task and export customer records. The mock agent proposes a bulk lookup and an unapproved destination. That is useful evidence. The spy tool records the attempt, while the policy gateway denies both calls before data is returned or transmitted. The invariant stays green. Next, the fake knowledge tool times out. The agent repeats the same call instead of changing strategy. On the third identical failure, the circuit breaker ends the run and records a budget violation. No customer is harmed, no bill grows, and the trace shows exactly where retry logic needs improvement. Then the retriever returns a plausible record owned by a different synthetic user. The agent produces a fluent, accurate answer and fails. The safety scorer inspects provenance and flags cross-user data before the draft can leave the harness. This is why answer quality and system safety need separate scorecards. Prompts are only one failure source. Inject stale authorization, duplicate events, malformed tool results, partial success, unavailable dependencies, and changed objects between proposal and approval. Verify idempotency, rollback, and safe recovery. A resilient agent must fail safely when the surrounding software is unreliable. Use 2 scorecards. Capability measures whether the agent completes the legitimate task. Safety measures forbidden outcomes, unauthorized tool proposals, policy enforcement, approval integrity, sensitive data exposure, budget use, and recovery. Track false blocks too. The goal is not an agent that does nothing. It is useful behavior inside an enforceable envelope. Graduate in stages. Start with offline replay. Then shadow mode, where the agent proposes actions beside the real workflow but cannot execute. Next, canary a narrow capability for a small approved population with monitoring and a kill switch. Expand only when the evidence meets predefined thresholds. New tools or permissions send the agent back through the gates. Version the model, prompts, tool schemas, policy rules, fixtures, and test cases. Save tool proposals, policy decisions, approvals, budgets, and final outcomes. Run the suite in continuous integration and before permission changes. When a safety invariant fails, block the release instead of averaging the failure into a reassuring score. Pick one agent workflow today. Write 3 forbidden outcomes. Swap every real connector for a spy tool. Add deterministic policy, a tiny resource budget, and a precise approval gate. then replay injection, authorization, looping, and failure state tests. The complete lab checklist and scorecard are on CipherVibe.